turn on the power switch. Set the switch to the on position. The power is always normal and the light indicates that the power is normal. The touch screen enters the initialization interface. Wait for initialization to complete. Initialization complete. Click the center of the screen. Select the user you want to log in as. The person in charge is set by default here. The password field is empty and the operator field is also empty. The user manufacturer requires a password. Refer to the manual for the password. Select the person in charge here and log in. Once the system is up and running, the interface will indicate that there are no alarms, and the program status will be green. The current interface is the home page, and the current user is the person in charge. Current date, time, and duration of operation. Below is the menu. You can access different functions by pressing different buttons on the machine. The middle section shows real-time data for the device. The status of the main unit. Stirring, valves. Green indicates open status. Light colors indicate closed status. The white text on the left is editable. The green text indicates monitored values. The right side shows the parameters for stirring, temperature, pH, and dissolved oxygen. The left side shows the data for the three peristaltic pumps. The first is the real-time speed of the pump. The second is the set flow rate of the pump. The third is the cumulative flow rate of the pump. The pump starts running from the current point and stops afterwards. It accumulates the cumulative flow rate of the added material. For example, the acid pump is currently at 300.9. Our test just now showed that 300.9 milliliters have been added. The same applies to the alkali pump and the feed pump. Stirring, the current speed is O. Set it to 60, then operate the stirring control button. There are two lines in the pop-up window. The first line shows the current speed. The second line shows the set speed. Since the current speed is now 0, if you want to turn it on, this area is light colored. If you want to turn on the mixer, click the Run button. Then click OK in the pop-up window to start mixing. Here, first cancel and close it. While the mixing is enabled, you can directly modify the mixing speed on the main interface, and then exit. When modifying the speed, be sure to note that the minimum value is 0 and the maximum value is 100. These values are already set in the parameter settings interface, and values outside this range are not allowed. The second button is for pH control. pH control is based on the current pH value and the current pH set point to automatically add acid and alkali to control. The pH set point of 7.0. Now turn on the pH control button. The first line shows the current real-time pH value. The second is the set pH value. The third is the current status of the acid pump and alkali pump. Because the acid pump and alkali pump are currently not linked, the pH cannot be started at this time. If you want to modify the status of this pump, you need to enter the peristaltic pump interface of the feeding control to modify the pump status. First, turn it off. In the peristaltic pump control interface, there is an acid mode below the acid pump, alkali pump, and material pump operation functions. There is an acid pump in the acid base mode that is currently in manual mode. This means that you can click on it separately in this interface to run it. Click Cancel. If you want to change it to automatic pH, you need to change this to linked and click the manual button. The second pop-up window asks if you want to confirm the modification of the acid pump. Operating mode. The current mode is manual. Click Confirm, and this area will switch to the pH control mode. The same applies to the alkali pump. The left side shows the data for the 3 peristaltic pumps, indicating that the current acidity and alkalinity are linked to the pH value. Then return to the pH control interface. In the pH control interface, you can now see that it is displayed as associated. Then click on pH warning, and after clicking Start, the acid pump and alkali pump will automatically add the acid and alkali according to the current pH value and set value. Then temperature control. Temperature control interface. The system controls the water inside the jacket of the reaction tank through heating and cooling, thereby controlling the temperature inside the tank. When stirring is not turned on during temperature control, it may lead to uneven temperature control. An alarm will be triggered in this case. This interface has 4 lines of parameters. The first line is insulation, currently 24.4, set to 37, with a water temperature of 33.8. Then the mode is now water temperature, which means that the current control object is water rather than the tank. Now we start the cycle, turn on the temperature. Control mode, modify the temperature control, and then click on the central control to run. These 3 buttons have a logical sequence. That is, you must first turn on the circulation pump. After sufficient circulation, it is generally recommended to circulate for about 2 minutes. Then wait until the sound of the water becomes quieter and circulation is sufficient, and observe the sight. There is a water level indicator on the left side of the controller. Only when the water level is at the optimal position can you continue to control it. Otherwise, you may need to add water. Then confirm your current working mode. Now, we change the mode from water temperature to tank temperature. Confirm the change of temperature control. Mode to tank mode. Click OK. The mode is changed to tank temperature, and the icon changes. Then we can turn on the circulation pump. Confirm Start. The pump has already been turned on at the site, so it can be turned off first. Then, when the circulation pump is turned on, only then can you start temperature control operation. Otherwise, the temperature cannot be controlled. The specific process and parameters of temperature control can be adjusted by pressing a button. Here are some process data for temperature control. Otherwise, the temperature cannot be controlled. And temperature control is like this. Then there is the feed control. The feed control is the same as the control method for the 3 peristaltic pumps mentioned earlier. The first row is for setting the flow rate and cumulative volume. The current motor is in use. When the current pump is in linked mode, it cannot be controlled manually. First, we start the feed pump. There is a manual. Control here. The icon on the right indicates the constant. Speed addition mode. You can modify its speed. And you can also modify its working mode. When you are in manual mode, you can also modify it to cycle mode. Cycle mode means that the cycle is 8 seconds or 3 seconds, operating in a cycle where it stops for 5 seconds. And a cycle operation icon will appear here. Return to manual mode. And here you can adjust the pump parameters, acid-base mode, and feed parameters. Another key parameter is secondary operation. Then enter the feed parameters and enter the pump parameter interface. This is the pump motor with 3 screws and some data about the pump and motor interior. If there is an alarm abnormality, you can check this interface. The auxiliary material parameters refer to the feed pump operating mode mentioned earlier. Modify. Then below are the clear buttons for the 3 pumps. For instance, the current cumulative total is 300.9 milliliters. To clear this flow rate, confirm whether to clear, press confirm. Please wait 2 to 3 seconds until the data has been cleared. Close this interface. The system features 4 valves. The first is the feed valve, VO1's feed valve, which supplies material via 3 pumps and a feed needle through the inlet valve into the tank. The second valve, VO2, is the exhaust valve. Exhaust valve 1. VO3 is exhaust valve 2. VO4 is the intake valve. Intake into the material. We can now manually open the material valve VO1. Open. Turning green indicates the valve is open. Closed. Similarly for VO2. Note the valve parameter interface here. The valve parameter interface contains 2 functions. The first is VO1. During feeding, specifically when the acid-base makeup pump is feeding, is the interlock set to VO1? If the checkbox is ticked, it indicates that once any one of the 3 pumps is activated, the VO1 valve will open automatically. Otherwise, in a state like this without a tick mark, the VO1 valve must be opened manually. During the second feed, pressure may build up in the tank due to gas, preventing the material from entering. Then one must opt to operate cyclically at this location, employing the venting method associated with VO2 and VO3, where no linkage is selected, meaning during acid or alkali feed replenishment. VO2 and VO3 remain inactive. Should I modify this setting? Changing it to VO2. The numerical value here becomes editable. The operational cycle is 30 seconds, with an active duration of 1 second. This means that upon detecting either acid or alkali feed pump operating in feed mode, VO2 will activate for 1 second every 30 seconds. When the acid-alkali auxiliary material pump ceases operation, the VO2 at this location will not function. Otherwise, the temperature cannot be controlled. As the acid pump is currently in interlocked mode, switch it to manual operation, and it may now be started. The current interface is VO1, which requires manual activation. Therefore, VO1 did not open automatically. Regarding the exhaust valve, the previously selected option was VO2. Otherwise, the temperature cannot be controlled. This valve did not open automatically, as it is programmed to activate only once every 30 seconds. Let us observe the parameters. Whether ticked or not, this operates every 30 seconds at the 30-second mark. For valves VO1 and VO2, the exhaust valve will operate for 1 second, now opening and closing. Right, that concludes this function demonstration. We shall now halt the pump and proceed to introduce the menu interface. The menu interface comprises these 5 sections, the first being parameter settings, which contains 3 distinct areas: control, calibration, and system parameters. Control pertains to associated parameters for temperature regulation, stirring, pH, feed, supplementation, and alarms. Calibration primarily involves temperature, correction, peristaltic pump calibration, pH calibration, and dissolved oxygen motor calibration. System parameters relate to key functionalities of the system: PLC status, data storage status, pH capacity communication status, system date and time, peristaltic pump data, and modification of user permissions. Additionally, parameter restoration, along with modifications to the system language, can all be accessed within the system parameters. Let us briefly review. The temperature control settings. This interface contains numerous marked parameters, which generally require no user intervention. Otherwise, the temperature cannot be controlled. Should any issues or anomalies arise, you may take photographs within this interface to examine the PID's operational status. The mixing process primarily controls the speed and certain data points on the machinery and hardware. Under normal circumstances, these settings should not be altered. Should the drive issue an alarm, this location will display a warning. The internal data of the drive can be viewed here. What are the current internal values, and what is the status? Regarding pH control, we employ a positional PID control for pH, with the parameters primarily located here, enabling monitoring of the control process. Auxiliary material control refers to the operating mode of the feed pump with 2 manual cycle options. Alarms denote absolute upper and lower limits for temperature, pH, and dissolved oxygen. That is to say, if the temperature exceeds 100 degrees Celsius, an upper limit alarm will trigger, while a temperature below 0 degrees Celsius will activate a lower limit alarm. Relative alarms operate as follows. For instance, if the current temperature is set at 37 degrees Celsius, the alarm system remains inactive. It has not been enabled. So let me set an upper deviation and a lower deviation, as the current temperature setting is 37 degrees, but the present reading is 24.4 degrees. Therefore, setting this here will trigger an alarm. A lower deviation alarm. The calibration interface monitors temperature, correction values, and raw readings, which generally need not be adjusted. The interface for the peristaltic pump corresponds to the calibration section of the pump. We shall provide a separate video detailing the calibration procedure for the peristaltic pump. Should you find that the value at this point has not been saved, you may reset to default settings with a single button press to activate the pump. Then proceed with the calibration. The pH calibration procedure is quite complex, and our method employs a 2-point calibration interface. The calibration method for 2 points is demonstrated in specific detailed videos. For oxygen calibration, we employ both 0-point and air calibration methods, with detailed instructional videos available. The state of analysis involves monitoring its operation to determine whether communication connections are established. Should any anomalies occur, this location will report an error. Data storage. This saves every 30 seconds. It is currently saving. If the cycle time is modified, the data will then be saved again according to this time. And this data should subsequently appear in the historical reports. The pH and dissolved oxygen readings are currently in good working order. The date can be amended. Click Start Modifying, then input the data. It is currently unavailable for input. The peristaltic pump refers to the data within. The peristaltic pump motor mentioned earlier. What is the current speed setting? The current auxiliary commands, alarm status, and position. User permissions allow us to log in. You may modify passwords, delete users, or exit user management to manage users and deactivate accounts. Parameter reset allows you to restore settings to factory defaults via this function. Language switching is available. The current setting is Chinese, but it can be switched to English. The second function provides historical data, alarm records, and trend analysis. We select the history log, where we can view the data within this interface, which was stored at 30-second intervals. Then input the corresponding start and end times, and proceed to review the data. Then I'll amend this to the 31st of September. Clicked View, and after filling it in, the entry time automatically changed to 9. Then click Refresh, and the date will update to the latest. You can also adjust its time. View all data, or insert a USB drive to export. Data can be exported automatically. It will automatically adjust based on the time, just now. Then fill in here. Then click Start Export. Insert the USB drive into this port. Then click Start Export. The number will automatically increment the quantity of exported entries. Should the USB drive malfunction or fail to be detected, a prompt will appear. Clearing this will remove the entire historical database. Should all data records be cleared? Data records constitute historical records and cannot be cleared here. Return to the home screen to access the alarm interface. The alarm interface is where we encountered an error during startup earlier due to a communication delay, resulting in a pH communication anomaly. An alert will be saved here. Subsequent operations follow the same procedure as the history log. As we have written to clear the alert data records. Confirmed, then refresh. The data has been cleared. Data curves may be used to review current data trends. It is generally inadvisable to monitor the situation via touchscreen. It can be exported to a computer for viewing. This place can only be viewed in passing. You can adjust its horizontal and vertical axis, as well as its vertical axis. Otherwise, the temperature cannot be controlled.